is not for the faint of heart. It is not the hardest thing ever, though. Not hard. However, I am going to make it as easy as I can for you. You're going to unpack this coat off.
Stay a while, E.
This is actually an old quiz that I gave. I have modified yours. It will look just the same, except it will say choose one of the balls. So I am going to give you 3, just like I did on this paper. You get 3, and you're going to pick one. So you'll look at all 3 of them. You'll have your reference. If you're here to take the quiz on Monday, all right, guys? If you're not here, then you better have, you don't get a reference sheet, all right? So we're going to be here. Take our quiz. All right, now listen. So your quiz that you get on Monday will look exactly like this, except it will say choose one of the following. And then on the back, you can choose another one to do for a little bit more extra credit. Remember, you already have 3 points extra credit. All right, got it? All right, so let's work through these together. The problems on the front and the back are the same. It's the same 3 problems. You will have 3 to choose from. So let's work through these. Every problem is different, but you use a lot of the same techniques. So this is the techniques you gotta get comfortable with. All right, so let's look at problem A. And tell me what you are thinking. What are you thinking when you look at this problem?
It looks like swap factor if it wasn't too different.
Okay, I heard somebody say get an equal zero. Stop. The purpose of this problem is to make this side boil down to that. All right? So we're not solving. We're trying to simplify this to see if it equals that. All right, Jimmy?
On the quiz, will they all be simplified?
Yes, it'll be just like this. Yeah. Yeah. Proofs. Yeah. Verifications. Proofs. Now, absolutely, that is the difference of squares. Okay? But wait, I don't think I'm going to do that. Because, where am I going to go after that? If I had a denominator that had a cosine plus 1 or something in it, I would want to do that because I could cancel. But that's actually going to make the problem bigger instead of smaller. So, what do you think, Colin? I think that's kind of what he was saying too. It does break apart. You can factor difference of squares, but oh, we're missing something big. What's 1 plus tangent squared? Yeah, that right there is secant squared. It's on your sheet, right? Now, what's this? Be careful. We know that 1 minus cosine squared is sine squared. If that isn't written on your sheet, it should be. We know that because sine squared plus cosine squared is 1. Right? This is not exactly what I have here, though, is it? It's flipped. Let's talk about that. What happens, would you agree 7 minus 4 is 3? And would you agree that 4 minus 7 is 3, but negative? When you subtract in the wrong order, you get a negative. You get the same number, but you get a negative. So 1 minus cosine squared is sine squared. If I subtract that in the other order, it will be negative. squared is 1 plus tangent squared, but don't do that because I'll just back you up. What is the definition of secant? 1 over cosine. If that isn't on your paper, oh my gosh, come on. 1 over cosine is secant, so this is 1 over cosine squared. Now I'm multiplying these two, right? Multiplying. When I multiply, I go straight across. So I get negative sine squared over cosine squared. What's sine over cosine? So again, you are not going to see this problem again. So let's discuss not the specifics of the problem, but the techniques. What did I do here? Whenever I see squared functions, a couple of things pop in my mind. One is difference of squares. But the other thing that pops in my head is, on my sheet, I have a bunch of formulas, identities, that use squares. So when I see all these squares, could any of those be useful? Well, heck yeah, that one's right on the sheet. And this one is backwards. Right, so I'm down here. So then what did I do? Change secant into 1 over cosine. And then what just happened? Okay? Why did you turn it into 1 over cosine? Because I had to end up with a tangent. And what's tangent? Sine over cosine. Yeah. And what else am I going to do? I keep moving, and what am I doing with the secant square? Not going back to this, because that would undo what I just did. So I have to think of something to do. All right, let's look at number 2. Now, it's always a good idea to keep an eye on where you're going. That's where I'm going. Notice that that is all signs. This is okay. Is it cosecant reciprocal of sines? Even though that doesn't say sine, I know it's related to a sine. The numerator is just different. I don't know. What do I know about cotangent squared? Do I know anything about cotangent squared? Cosecant squared minus 1, right, from my sheet. So cosecant squared minus 1. Now this time, I'm going to look at that and think about factoring it, because I have the same thing in the denominator, and I'm hoping I'm going to be able to cancel. Right? Are you with me, guys? See how we're thinking? So, how does the numerator factor? Cosecant plus 1, cosecant minus 1. And these now will go away. Okay, so let me, I don't want to harp on this point, but do you see why it was beneficial to factor that difference of squares? And it would not have been beneficial to factor this one. Because this one had a denominator that I could cancel. Alright, so what am I left with? I'm just left with cosecant minus 1. So now, Harper, I'm going to do exactly what I did a minute ago. Techniques are the same. What is cosecant? What else? Why did I do that? Because that's what I want to end up with, right? fraction here. What do I need for a common denominator? So this one is going to need to be multiplied by sign. One minus sign on top, one minus sign, and sign on the bottom. My common denominator is sign. Numerator is one minus sign, which is exactly what we want. Jim, don't have that greatest look. It's very logical.
No, I feel good about it.
One more. And remember, you get to pick. And you might try one and then not go anywhere, so you have to pick another one. A blank paper is a 0. You can get partial credit if you do anything that's right. It may not end up where you want it to be, but you have done something.
Should we do all three of them and then?
You think I have no life? Yes, you're right, I have no life, but no, I'm not good. You're gonna, yeah, you can start one and then cross it off and then do another one. Because you're gonna choose a problem for me to grade, and then on the back, a problem for a bonus. Alright, this is the worst of the three, I think, in terms of the way it looks. It's scary looking. There's no squares, which means you're not gonna do any of those substitutions like we were doing, right? There's no way you're gonna factor that numerator and cancel anything. So I think the only thing we can do is change this mess into sines and cosines. So on the top, I have cosine times cosine over sine. And on the bottom, I have 1 minus sine.
Wait, so you change the cotangent to cosine?
Yep. And I'm like you, I have no idea where I'm going here. I'm just trying to think of something to do, so I get a point. So now I can look at my numerator, and my numerator is cosine squared over sine over 1 minus sine. Alright, so when I multiply, this is a multiplication problem. You see how you get cosine squared over sine? And that's all over the 1 minus sine. Oh, are you hearing Michael up here? You hear what he said? He said, I don't know what's going on here, this looks terrible, but what do I know about cosine squared? It's 1 minus sine squared. Let's try that. 1 minus sine squared over sine. All over 1 minus sine.
So we can do factors.
So now, he's saying, I see some overlap here, so maybe I should factor that. So I have 1 minus sine, 1 plus sine, over sine, all over 1 minus sine. We'll leave that there so I can remember. Oh, don't forget, I still have this minus 1. I'm just carrying that minus 1 around. Now, if you are comfortable a fraction divided by another fraction. Would you agree with that? And if I keep change flip, that's a fraction divided by the fraction, which is times its reciprocal. So notice that what was the numerator actually ends up in the denominator. And so the general rule is if you have, a big fraction right here over another fraction, if you have the same thing in the numerators of those two fractions, you can cancel them out. If you have the same thing in the denominators, so nothing cancels here, but if there'd been a sign here, I can cancel those out. So if they're in the same position on the top fraction and the bottom fraction, they're going to cancel. All right, so what have I got? Well, now that I've canceled that out, I have 1 plus sign over sign, and my denominator is now going. Well,
Oh, because, okay, I got it.
So now I'm here. So I need a common denominator now, so I can subtract. So my denominator is sign. And what's my numerator? 1 plus sign minus sign. So 1 plus sign over sign minus sign plus sign. What happens? 1 over sign, which is indeed cosecant. So again, tomorrow, you're gonna have 3 chances to prove yourself. There's one, you'll find one to do. And you'll take it as far as you can take it.
I mean, I know the obvious, like, that is a sign, not a sign. But my first thing was that you can cancel the bottom and the top.
Only a times problem. If you are multiplying fractions, you can cancel top and bottom. If you are adding or subtracting, you need a common denominator. Okay? So you remember that too, in algebra stuff. Okay? Good? All right, we're gonna do what we did yesterday. We're gonna have team effort here, we're gonna do one more. I don't know, more practice. So I'm just gonna randomly pick one like I did yesterday off of this practice sheet we got. Remember, the variable doesn't matter, so if you don't like A's, you can make it X's or something else. Okay? This happens to be number 7, but it really doesn't matter. Because you are going to do it. Well, I haven't taken attendance yet. It matters. Come on, we need a volunteer, we need somebody to do something.
So it's where it's going. You gotta put it on the reference sheet.
I was gonna go up and do, I was gonna change the sine squared to 1 minus cosine, but it's still, it has to be a flip, because it's negative. Right?
I got this.
Well, that's what I thought, because
Sine.
cosine squared plus, or sine squared plus cosine squared is 1.
But you're getting
But
it
it's a
to,
negative,
so
so-
it has to equal that. It can't just be negative one. You have to choose the side.
So I threw a 2 in there.
It's not.
Jimmy, what do you think?
Yeah, that's like the steps. Yeah, you just come right out. I'll just combine them and then it's minus 1. Yeah.
Now, this is fine, this is fine. General rule of thumb is, if I can follow what you're doing, it's all good. But some of you may not be following quite as well because you haven't done this much. What is sine squared? What do I know about sine squared? It is 1 minus cosine squared. So I have cosine squared minus 1 minus cosine squared. And since I am subtracting 1 minus cosine squared, that turned into a negative 1 plus cosine squared.
Yeah.
And that's how we got 2 cosine squared. Alright? Now, on a scale of 1 to 10, that was a 0. Now, let's work a little bit more. Alright, good job on that. It would have been alarming if you couldn't do that one, so that's good, good. Let's do one that's a little bit more, challenge. This is 11. Now, this one is also not too bad, but it's definitely harder than the one we just did. But it's not bad at all. I'm gonna help you get jump started here. Unless someone has an idea.
That's square. So 4? Can you square both sides?
You mean square root both
Yeah,
sides?
square both
Well,
sides.
no, you can't, because remember, you're supposed to be changing this side into that side.
Oh.
So you can't mess around over here, because you wanna end up with that. Also, remember that when there are minuses and pluses, Blake, square rooting, you can't simplify that. You wouldn't even be able to do anything with it even if you could do it. Okay, idea?
We factor out the tan squared.
Can we factor out a tan squared? I think so. So what would we have left? If we factored out a tan squared,
Tan squared.
tan squared plus 1?
Yeah.
Wait, tan squared plus 1.
Oh, I got it.
Isn't that something?
Secant squared.
That, this right here is secant squared? What's that? What's tangent squared? Secant squared minus 1? Right? And now I'll just distribute. What's secant squared times secant squared? Secant to the fourth? And lo and behold, you did it. You did that pretty much on your own, because the idea came from back here and down.
Just takes one
Yeah.
step.
Nice work. Nice. The rest of you following along here, you see what happened? Okay, one more, and then we gotta move on to something different. Let's see. How about That was too easy. How about this one?
Separate. There's the
Magnetic. Guess the
long.
magnetic.
The Mac Daddy.
Which one?
What number?
Give us the Mac Daddy.
Huh? I was gonna do 13.
Oh. Three different letters in there.
You use whatever letters you want. Okay. Now, again, it's about techniques. In this guy over here, we factored first, and then we recognized we had all these squares. And when you have those squares, you very often use the things from your sheet, right? Now this guy, there is no factoring to be done, and there are no squares. So, what could we do?
Do like
We did it a couple times earlier. Harper, you asked about it. What can you do?
1 plus.
Secant is 1 over cosine.
Exactly. Secant is 1 over cosine.
I was sure this one was weird.
Now, it looks worse than it did before, but believe me, this is gonna work. It's gonna be so wonderful. Now, this is called, run into it before, this is called a complex fraction. It is a big fraction that has little fractions inside of it. The easiest way to tackle it, not the only way, but the easiest way to tackle that is to look at all the components of the fraction. This is an algebra thing. Look at all the components of the fraction. The common denominator of the components is cosine. That's the only denominator, right, of the components. So multiply each component by cosine. Because what that will do, can you see what it's going to do? It's going to cancel that out. And now, you don't have a fraction within a fraction. Now you have cosine B plus 1 over cosine squared plus cosine. So in the beginning, we had this big fraction with a little fraction inside of it. So we cleared that fraction out by multiplying by the denominator.
You factor out a cosine at the bottom.
On the bottom, there's no canceling right now. Nothing cancels right now. But we can factor out a cosine on the bottom. And what will that leave me with if I factor out a cosine?
Cosine plus 1.
Cosine plus 1, oops, cosine plus 1. And now I can cancel. And what am I left with? 1 over cosine. And 1 over cosine is secant. I'm starting to feel a little bit. Alright. So you guys did a really good job with that one problem today. The one I thought would be a little harder for you. So I'll give you another bonus point for that. So I just need to remember. Okay. So tomorrow's quiz could actually turn out to be a really good thing for you, as scared as you are of it, because you have the opportunity to do a bonus question on the quiz, and I've given you 4 points already.
What's
Right?
that out of?
still need your reference sheet. And we are going to
I need to make your step go up, or what? What's your step? Up? Thursday? Skiing?
we are going to see.
I'll tell you reaction for me.
You're only gonna get a problem or two done. But these are not hard at all, but they do require you to remember some stuff. Okay, so we have our reference sheet out. And the directions say find the exact value of the sine of 15. Now, in chapter 4, what were the angles that we could do exactly? There were only a small number, 45, 30, and 60, right? 15 is not in that list. However, 15 is 45 minus 30. So in other words, I can rewrite 15 as two of my special angles. I could add them or subtract them either one. In this case, I'm going to be subtracting.
You divide.
So I am going to use that. That's another one. Today we're just adding or subtracting. All right? So today, we are only adding or subtracting our special angles. And one more time, our special angles are 30, 45, and 60. Okay? Now, on your sheet, this isn't a distribute. Please don't think you're just going to distribute. That's not how it works. But on your sheet, there is a formula or an equation that says the sine of, I gotta make sure I have the letters right, u minus v. You see that one? Now that is exactly what I'm doing here, you guys. I'm finding the sine of an angle minus an angle. And according to the sheet, to find the sine of an angle minus an angle, you take the sine of the first one times the cosine of the second one minus, I don't remember what order I had it written in, but it's the cosine of the first, sine of the second. Okay, so what's that going to be for my problem? Sine 45 cosine 30 minus cosine 45 sine 30. Nope. This is exact. Remember when it says exact. So there are 4 numbers that you need to know. Okay, so look over here for a minute. There's a 30-degree angle. It's a blast from the past. And a 30-degree angle is 1, 2, 3, like that. So when I have to find I'm doing the 30s. The cosine of 30 is root 3 over 2. And the sine of 30 is 1/2. If you want to draw this, your reference sheet's going to get kind of crowded, but if you want to draw this little triangle on there, you can. I gave you that on the last test. I gave you that, so you can have that. And now I have to do 45. So remember the sides of a 45 are 1, 1, root 2. Right? So I want the sine of 45. So that will be 1 over root 2, which I'm going to write as root 2 over 2 this time since I'm doing arithmetic. So remember, 1 over root 2 is the same as root 2 over 2? Yeah, because we're doing arithmetic here, so we wanna get punished. I'm gonna flail you. So we're gonna use root 2 over 2 here, and the same over here. Both sides the same.
So when it says like U and V, just as U always represent like the 45 and
And that's
okay,
it.
U's always
It
just
won't always be 45 and
U's
30.
is always the first one.
U minus V. All right, now, see this minus right here? Nothing's gonna cancel, okay? I'm multiplying these together, so I get root 6 over 4. And I'm multiplying these together, and I get root 2 over 4. They don't combine. I can write them as one fraction because they have the same denominator. And that's my answer. Everything you need is on your reference sheet, except you have to come up with this combination. How am I gonna get 15? All right, so when I look at the next one, it's 165. So cosine 165. Okay, now, you're thinking, Mrs. Ford, you told me that I could use 45, 30, and 60, and there's no way to add 2 of those and get 165. And you're right. But what I need you to remember is, when I look at a 60-degree angle, for example, I could have a 60-degree angle in quadrant 1. But what if I had a 60-degree angle in quadrant 2? What is the actual measure of a 60-degree angle in quadrant 2? 120. So not only can you use 60, but you can use every 60. So 60, 120, this one would be 240, and this one would be 300. You can use all of the 60s, and all of the 45s, and all of the 30s, okay? So if you want to add to your reference sheet, okay, here are my 60s, right? What would be my 30s?
30.
Make this a 30 now, what would they be? Come on now. 150. No. 210. 180 and 30. And then all the way around except for 30 would be 330. Right? So all those are eligible angles to use. And then how about the 45s? What are the 45s? Obviously 45. And then you anywhere one. And then,
135.
what?
135.
135, very good, Jimmy. And then third quadrant would be 225, yep, Harper. And fourth quadrant, 315. Okay, is that you, Royce? Good job. Mr. CHSI. I'm so glad you guys didn't throw that stupid head. Why do they throw that all the time?
I don't know. They don't have it. It's like adding into everything.
All right. So these are the angles that we can use in our combinations. All right, so with that in mind, find 2 of these. You can only use 2. 2. You want them to either add up or subtract to be 165. So can you find 2? They either add or subtract to be 165. And there are lots of answers. 135 and 30, I heard. Myself, I was thinking 120 and 45. There are lots of options. The answer will be the same. the work will look different, but the answer will be the same. So let's go with this. So now look on your sheet, and now we're looking for the formula for u plus v cosine u plus v. That formula says cosine u cosine v minus sine u sine v. Everybody find it? So our u is 135, our v is 30. Here we go. Cosine 135, cosine 30, minus sine 135, sine 30. Everybody good? So now, I'll draw a picture of 135, which is over here, and that's one of my 45s, right?
Yeah.
So negative 1, 1, and 2, don't forget that negative. That's my 135. So the cosine is negative root 2 over 2, and the sine is positive root 2 over 2. That is 1 over root 2, root 2 over 2. And then 30, I mean, you can draw, I don't know if you necessarily want to try to draw all of these, but you can draw your 45 for sure. And then your 30, did we already do 30? Yeah, we already have the 30. So the cosine of 30 is root 3 over 2, and the sine is 1/2. So multiplying negative root 6 over 4 minus root 2 over 4. Do not add those together. Negative root 6 minus root 2 all over 4. Now what do you notice about that answer and the answer we got to our first problem? They're very similar, right, aren't they? And that's going to happen because we keep using the same numbers over and over and over again. So the answer is always going to look like that.
Is there ever a time where like we're not gonna know like we're gonna do like a squared, b squared, c squared, like find our other points, or like we'll always just be like
The only angles we can do are these. All right. So Colin, you can go ahead and go. The rest of us are going to do one more problem. Tangent 195. So what is the first thing you are going to do? Figure out what angles you are either going to add or subtract. It doesn't matter, you have formulas for both. And I just erased my options, but you have them. So the tangent of 195 is going to be the tangent of what?
225 minus 30.
What?
225 minus 30.
225 minus 30. That may not be what you thought of, but is it okay? Yep. So here we go. Formula for the tangent of u minus v says tan u minus tan v over 1 plus tan u tan v. All right, everybody find that on your paper? What's the matter? So we're going to have tan 225 minus tan 30 over 1 plus tan 225 tan 30. Is that all right? Now, I need to figure out 225. Now, 225 is one of my 45s, right? So negative 1, root 2. Tangent will actually be what? right?
Yep.
So that's easy. So 1 minus 130. And now that's gonna be down here too. Okay? This and this are the same, so I'm gonna put 1 in for both of those. Now I need my 30. Well, we drew our picture already. I told you to keep that picture on your sheet. You want tangent. So tangent, it's root 3 over 3. It's 1 over root 3, right opposite over adjacent. But we're gonna rationalize it now. I didn't make you do that before, but we're gonna have that fraction inside a fraction, and it's just gonna be easier to rationalize it. So instead of 1 over root 3, we're gonna write root 3 over 3 in both places. So I'm gonna have 1 minus root 3 over 3 over 1 plus root 3 over 3?
Oh, the one is supposed to.
Yeah, that's just multiply. So, everybody good with that? Now, friends, we talked about that a little bit ago. That's called a complex fraction. It's a big fraction that consists of little fraction pieces. Multiply everything by 3. So everything by 3. So all 4 components times 3. So what are we left with?
3 minus root 3 over 3.
3, yeah, those are gonna cancel. So 3 minus root 3 over 3 plus root 3. That okay with everybody? One more step. No, nothing cancels. Please don't cancel anything here. Why can't I cancel? Pluses and minuses. Alright? So now, we're going to multiply by the constant. Remember that little trick? What's the conjugate? You just change the middle sign and start foiling. So here I go, I'm foiling. So I'm gonna have on top, I'm gonna have 9 minus 3 root 3 minus 3 root 3 plus 3. When you multiply root 3 times root 3, you just get 3. And then on the bottom, I'm gonna have sort of the same thing. 9 minus 3 root 3 plus 3 root 3 minus 3. Foil. We hate the tangent because there's so much work involved. These cancel. That's the only thing that cancels. Those are gone. What do I have on the top?
Hello, Cathedral. Before we get started this morning, I wanted to give a quick reminder that there will be Mass in the Chapel today at 11:50. Also, we are going to go into the Champions Walk. Wrestling coaches will parade from Cunningham alongside Loretto into the hallway of the Unified Media Center, through the Innovation Center, and through door number 4. Please move your students out to the hallway to join them and cheer them on to give them all the Irish love and support.
That's a
Now
lot.
let us pause and be mindful of all of God's blessings. In the name of the Father, Son, and Holy Spirit,